let's just define a rational equation. Okay, so rational equation, whoops, I want to do that, is an equation that includes at least one rational expression. Okay, so for example, if you had 10 over x equals 2, okay, this is in fact a rational expression because the left side is a rational expression, right? It's a fraction that has algebra in it, and the denominator is a polynomial. Numerator is just a number, but there you have it. Now, anyone know the solution to this? 10 divided by something equals 2. X equals 5. Okay? So in fact, you've solved simple rational equations many times before. Okay? Now, how do we solve these when they're more complex, right? This one you can solve by inspection. Inspection means you just look at it and you're like, I know what the answer is. Okay? When they're more complex, we can't do that. Okay? So just like we've done with all of the other things that we've done with rational expressions, two key steps are going to be involved. One of them is factoring, and the other one is stating your non-permissibles. Okay? So step 1, factor everything. Okay? Step 2, and I like to do this as the second step, but actually you could do it later on, is state non-permissible values. Okay? Now, in the third step, we're going to essentially do what we did with that last linear equation. We're going to multiply the entire equation by the least common denominator. So actually, maybe part of step 3 is identifying. There we go. Identify the LCD, multiply the entire equation by that LCD. Okay? Now, what happened when we solved that linear equation is that all of the denominators ended up canceling. Okay? So we want to make sure to do that too. Okay, now when that happens, and we'll see this, I know it seems kind of abstract as I'm just writing things down. When that happens, you're actually, if you don't have any denominators with algebra in them, you don't have a rational equation anymore. So in doing this step, we actually change the nature of the equation. Okay? And in this course, we're either going to change it to a linear equation or a quadratic equation. Okay? With more complex expressions, you might also get a cubic or a quartic equation or something like that. But in this course, it will either be linear or quadratic. Okay? So this will change the nature of the equation to linear or quadratic. And that's good because we know how to deal with a linear or quadratic equation. Okay? So once we change the nature of the equation, then we got to solve that resulting linear or quadratic equation. So that's step 5. Now, all of that practice that we did at the beginning of class today and also the Friday before the break was just practicing step 5. how do you solve a linear or quadratic equation? Okay. And then the last step, which a lot of people forget about, is this. You have to check your answers to make sure that your answer is not one of the non-permissible values. So this last step is that if you happen to get an answer that was an MPV for the original equation, you have to throw it out. And that type of answer has a special name. It's called extraneous. Okay? So, and extraneous solutions or extraneous roots, they're sometimes called, can occur whenever we change the nature of an equation. Because when you have a quadratic or a linear equation, there are no non-permissible values. Okay? But if we get something that actually doesn't make sense in the original equation, it's invalid. Okay? So step 5, or step 6 rather, check your answers against the non-permissible values to see if they are extraneous. Okay? Now, as you're just finishing writing that down, what I will mention is that sometimes you don't have to go through every single step in every single question, particularly the first one. A lot of times you will get an equation that has already been factored, so you don't need to worry about that. So, you know, but this will be a step-by-step process that you could go through for every single question. And if you follow it and check each step, you should be good to go. Okay? All right, so let's start off. Determine the solution to the equation 3 over x plus 3 equals 9 over 4x plus 7. Okay? All right, so first thing, can anything here be factored? No. Everything's fully factored. Okay, so that's good. Non-permissible values. Okay. From this first expression, what would the non-permissible value be from that? -3. Okay, so x cannot equal -3. What about from this one? -7 over 4. Okay, yeah, so if you can do that in your head, great. If you can't, remember that you can set the entire factor not equal to 0 and then solve for x, right? So the first thing I would do here is subtract 7 from both sides, and I will get 4x cannot equal -7, and then divide by 4. And we get x cannot equal -7 over 4. Okay? So those are my two non-permissibles. Okay? Now, the denominators have been completely factored. Are they identical? Are the factors identical? No. So in that case, the least common denominator has to be the one times the other. If everything is factored and the factors are not identical, then the least common denominator is two of them multiplied together, right? Think about denominator of 3 and denominator of 5. The LCD there would be 15, because 3 and 5 do not have any common factors. Okay, so once we identify the LCD, I'm going to rewrite this and give myself lots of space, because my next step is to multiply everything by that LCD. So, and what I mean by everything is every single term on each side. Whoops, let's fix that. And then here, x plus 3 times 4x plus 7. Okay, so I'm multiplying everything by the LCD, and now certain factors will cancel. So on the left side, I can cancel this factor of x plus 3 with this denominator of x plus 3. And I can cancel on the right side the factor of 4x plus 7 with the denominator of 4x plus 7. And what I end up with is a linear equation. Okay, so if I kind of regroup, what I have here is 3 times 4x plus 7 equals 9 times x plus 3. And this is now linear. So I got to solve that. Okay. For this particular linear equation, we got to do some expansion first. So this will be 12x plus 21 equals 9x plus 27. Okay, where would you go from here? Yeah, so essentially, you want to start collecting your x's on one side, collecting your numbers on the other. You can do that on one step, or you can do it in two. So if we start by subtracting 9x, so that we're collecting these guys together, then we're going to have, 3x plus 21 equals 27. Okay, and then what? Yeah. Right, subtract the 21 so that now I'm collecting my numbers on the other side. Okay, so this will give me 3x equals 6. So what does x equal? 2, right? Divide by 3. Okay. Now, we're almost done, but we need to go back and check what were the non-permissible values. Because if 2 was a non-permissible value, we got to throw this out. Okay? So if you go back and look, 2 is not one of the non-permissible values, so this is the solution to this equation. Okay? Did you have a question? Yeah. Oh, okay, sorry. All right. So far, so good? All right. Let's try another one. Determine the solution to this equation. 1 over x minus 2 equals 3 over 2x minus 4. Yes?
So last week when we were doing the same sort of thing, and we kept the denominator.
Yes.
So why aren't we doing this?
Okay, very good question. So the question was, last week we kept the denominator, and this week we kind of eliminate it. The difference is that in this week we are dealing with equations. And last week we were dealing with expressions. So what I'm going to do to answer that actually is add a page and just show you guys the difference between the two. Okay? If I said, what is 2/3 plus 1/6? Okay, I'm just adding two fractions together. Okay? In this scenario, I need to think about what my least common denominator is, get the least common denominator, so I have to multiply, it's 6, right? So I'll multiply this by 2 over 2. And this will give me 4 over 6 plus 1 over 6, which is 5 over 6. Okay? Now, on the other hand, if I had, let's say, 2x over 3 plus 1/6 equals 5/6, something like that. I don't know. Okay. Now, because I have this equal sign here, it kind of acts like a fulcrum where there's balance. Okay. And so I can, in this scenario, multiply everything by 6 and eliminate the denominator. If I took this and multiplied it by 6, I would not have the same value as what I had before. Okay? Here, though, all I care about is that this stays balanced. So if I multiply this by 6 and multiply this by 6, then let's see, this is going to be 12 over 3. So that's 4x plus 1 equals 5. Okay? And now I can keep going. But if I don't have that equal sign there to sort of keep things balanced, and I just multiplied stuff by the LCD, I wouldn't have an equivalent expression anymore. Okay? So the main difference is when you're dealing with an equation, you can eliminate the denominator because you're multiplying the left and right side by the same amount. If you have an expression, you can't do that. Does that help a little bit? Yeah? Okay. It is a really, really common mistake, though. And it will be something that we'll talk about later on this week, right? And really, we're kind of just looking at one type of question at a time at this point. But later on this week, we're going to say, OK, the big three processes are multiplication, division, addition, subtraction, and solving equations. So how do we differentiate those three? All right, let's look at this guy. Is everything factored? Is there anything we can factor there? Yeah. Yeah, so I can factor this guy, and I'll get 1 over x minus 2 equals 3 over 2 times x minus 2. OK. All right, let's talk about non-permissibles. What are the non-permissibles? So this is kind of actually step 1, right? X cannot equal 2. Because 2 minus 2 is 0. OK? Step 3, what's my LCD? What is the least common denominator between those two? Yeah?
2 by x minus 2.
Right, yes. So remember with your LCD, you have to be able to see all of the factors from each denominator, but you don't want to repeat them if you don't have to. So if you start with this one, I need an x minus 2 in there. And then if I look at the second one, I've already got an x minus 2, but I'm missing the 2. OK? And we're going to multiply everything by that. So I'll multiply on this side by 2 times x minus 2 and 2 times x minus 2. Okay, now on this side, on the left side, this is kind of step 4. Right? These cancel. And on the right side, the entire denominator cancels. Okay? And so what I'm left with is this. 1 times 2 is 2 equals 3. Okay? That's a little interesting. 2 equals 3. When does that ever happen? Never. Right. So if you end up with something that happens never, there's no solution. There is no value of x that will make this true. Okay? Now, I do want to show you another way that you could look at this, although I hesitate to do that because in my experience, it can, how should I say that? It can cause problems. It can make people make mistakes. Is you could cross multiply. Okay? Now, if you cross multiplication, you guys are familiar with that? You go like that and like that. I don't like it. And I don't like it because I think that it makes people disconnect from what's actually happening mathematically. Okay? But I do want to explore what would happen if we did something like that. So you can see why this, another way as to why there might not be a solution to this. Now, cross multiplication, by the way, is not just making that go up there and that going up there. It's actually multiplying the entire equation by both denominators. And then things cancel. So I'm going to make you go through that. I'm not going to sort of take the shortcut. Okay? Now, if we multiply by both denominators, you are multiplying by a common denominator, but it's not, in fact, the least common denominator. Because now, essentially, you're multiplying by, like, x minus 2 times x minus 2. Okay, but you can do it if you want. Most of the time it leads to problems, but okay. Now when we just put that up there and that up there, that's not mathematically what happens. What happens is that you multiply both sides by both denominators. Oh, I'm totally going to run out of room here. Wait. I got to move this over. Okay, let's do it up here. Okay, so if I start with the same equation, you got to give yourself lots of space in this topic. Don't squish. Okay, so I'm going to multiply both sides by both denominators. Okay, and again, not the least common denominator, but it's mathematically sound. This is what happens in cross multiplication. These cancel, and these cancel. And so what you're left with is this times that and that times that. Okay? So on the left-hand side, we've got 1 times 2x minus 4. And on the right-hand side, we've got 3 times x minus 2. Okay, now if I expand here, this guy's still just 2x minus 4. This side is now going to be 3x minus 6. And I will maybe, let's see, I'm going to subtract 2x from both sides. And I'll get negative 4 equals x minus 6. And then I have to add 6 to both sides. And I get x equals 2. Okay, well that's interesting, because in the one way I solved, I didn't get a solution. Now I'm getting x equals 2. Yes?
When we compare it to the NPVs, x can equal 2.
Exactly. This is a non-permissible value. This is an extraneous solution. So in fact, this is not a solution to the original equation. We have to throw this out. Okay. Now the reason why we got an extraneous solution doing it this way and we didn't the other way is because we didn't multiply by the least common denominator when we did that cross multiplication piece, right? But at the end of the day, you should be able to see that there is no solution to this equation. Okay? Questions? Oh no, there's one more. Okay, let's try this guy. Determine the solution to the equation. X minus 2 over 2x equals 1 over x minus 3. Okay, so is there anything that we can factor here? Anything to factor? Nope. Okay. Non-permissible values. What are my non-permissible values? From the first denominator of 2x, 0, right? And from the second denominator, 3. Correct. Okay. So those are my non-permissible values. What is my LCD? Yeah. The denominators are factored and they're not identical. If they are factored and not identical, the LCD is the one times the other. You can't take part of one and combine it with part of the other, okay? Okay, so now the next thing we need to do is give yourself lots of space and multiply both sides by the LCD. Okay, and now we get to do the fun part, which is all the canceling. Okay, so On the left side, the 2x's cancel. And we're left with x minus 3 times x minus 2. And on the right side, the x minus 3's cancel. And so we're left with 1 times 2x is 2x. Okay. So anyone want to hazard a guess as to what type of an equation this will be? Quadratic, yeah, because this needs to be expanded on the left, right? And so when I expand, I'm going to have an x times an x in there, which will make an x squared. So that's going to be the next thing that I do, okay? X times x is x squared, and then minus 2x. Then move on to multiply by the negative 3, minus 3x. Negative 3 times negative 2 is plus 6 equals 2x. Okay, where do we go from here? Yeah, so I would collect these 2x's on this side. So you can do this all in one go if you want. Right? And then essentially what you're going to have is on the left side, x squared minus 2x minus 3x minus another 2x. That's negative 2 minus 3 is negative 5 minus 2 is negative 7. Minus 7x plus 6 equals 0. Good. So once you realize that it's quadratic, you got to equate to 0. Okay, now what? Quadratic formula, yes. So firstly, what's our value of A? What's our value of B? And what's our value of C? Right, 1, negative 7, and 6. And the quadratic formula, I personally like to write it out first so I don't make any substitution mistakes. Minus B plus or minus the square root of B squared minus 4AC all over 2A. Okay, and then I replace the letters with brackets. And then I can sort of plunk in. So my B is negative 7. And this is also going to be negative 7. For A is 1, C is 6, all over 2A is 1. Okay, so this is the mistake that I was talking about that people sometimes make, particularly when B itself is negative and you don't put the negative sign in again. Negative 7 is actually positive 7. So this is the piece that I would do first, okay? Negative 7 squared. Why do I keep closing my calculator? Minus 4 times 1 times 6. Let's see. And you want to enter it in exactly as you see it, right? So the negative 7 needs to be in brackets. Minus 4 times 1 times 6. 25. Okay? So 7 plus or minus the square root of 25 over 2. What is the square root of 25? 5. Yeah, so this becomes 7 plus 5 over 2, or 7 minus 5 over 2. Okay, so 7 plus 5 is 12 over 2, which is 6. Or 7 minus 5 is 2 over 2, which is 1. So x equals 6 or 1. Okay, are we done? What's the last thing we got to do? Check non-permissibles, yeah. And in this case, I believe we're okay. Yes, so we're good. Those are the answers. Now, one thing, just so that some of you guys might be thinking about this, this one is actually fairly easy to factor. And whenever your solution is rational, like these two solutions, it indicates that, in fact, you could have solved that by factoring. Okay? Now, I'm only bringing this up because If you're good at factoring, it's going to be way faster for you to solve this equation by factoring rather than using the quadratic formula, and probably more accurate. So please feel free to go ahead and do that if you're comfortable with it. Okay? All right, so I want you guys in the next few minutes to try these practice questions 1 and then 2 and 3. And then we'll see where we're at. I think that might be where we leave off today, but we'll see.